about elimination, and then we'll talk more when these problems are straight out of your book, so you should be able to go back to your book. You'll notice that I put the numbers on the side. Okay, so our first problem, Jeanette is trying to find the intersection point of these two equations. Okay, currently the only way that we know how to do this is by using something called substitution. Okay, but in order for you to use substitution, it had to say y equals or x equals, or you could have them both say y equals or x equals. Okay, but we can solve this and make it say y equals. So let's take this second equation right here. So negative 3y plus 5x equals 10, and let's solve it for x. Okay, so to move the 3y over to the other side, remember if it's negative on the left, then when I move it over, it's going to become positive because I have to add it. 5x equals 3y plus 10. And then I could divide by 5, but you have to divide all of these things by 5. Now, this says x equals 3 divided by 5. 3 divided by 5, you can't do. It would be 3 over 5y plus 2. Okay, right there, I feel intimidated. Okay, and I know that some of you do too. You feel intimidated that this is a 3/5. Okay, there is an easier method to this. Okay, notice in our original equation, 3y plus 2x equals negative 2, and negative 3y plus 5x equals 16. Notice 3 and negative 3 are special. 3 and negative 3 cancel each other out. They make 0. Okay? That makes our life really a lot easier. We can use what we call the elimination method because a positive 3 and a negative 3 eliminate each other. They eliminate each other when we add. So we can add these things right down. So these would cancel each other out. When I add 2 and 5, I get 7x. And when I add 6 and negative 2, I get 14. Notice when I add those two things straight down, I get just 7x equals 14, which everyone in this classroom knows how to solve. You know that to get x by itself, I divide by 7 and divide by 7. Therefore, I get x equals 2. But remember, we need an x and a y. So right now we have our x for our point of intersection. To find our y, we're going to take this x and we're going to plug it back into one of the originals. It does not matter which one. I'm going to take this x and I'm going to plug it right here. Now, it's not as simple as when we use substitution. It becomes a little more difficult here. So this top equation says 3y plus. Instead of writing out on my paper 2 times 2, I'm going to actually do 2 times 2. 2 times 2 is 4 equals negative 2. Okay, now I have a second equation that I need to solve. So I subtract 4 from both sides. I get 3y equals negative 6. Then I divide by 3. So therefore my y is negative 2. So my point of intersection is 2, negative 2. We would have gotten the same thing using substitution, but you would have had a really ugly fraction here that you would have had to work with. And I know we get very intimidated by fractions. Okay, so here's some notes about elimination. A method for solving system of elimination is a method for solving system of equation. This key step is using the elimination method is to add. Please cross out the words or subtract. We are not going to subtract, we're only adding both sides of the two equations to eliminate one variable. For example, the two equations in the system below can be added together. You can add these together, and the positive 2 and the negative 2 will eliminate each other because they will make 0. Okay, that leaves you with 7x equals 10 and 4 make 14. That's where they got the 7x equals 14. Okay, and now we can simplify or solve. So we divide by 7 on both sides, so we get x equals 2. So 2, comma. Okay, once again, it doesn't matter which one of the originals you plug the 2 into, but you got to plug it into one of the originals. I am going to plug this 2 into this x down here. Okay, don't write out on your paper 2 times 2. You know what 2 times 2 is. So 2 times 2 is 4, minus 2y equals 4. And now I have a second equation I can solve. So I subtract 4 from both sides. I get negative 2y equals 0. And then I can divide by negative 2. And I get 0 for my y value. And there is my point of intersection. Okay, you're going to try this one on your own. The sub is going to pause the videos. What I want you to notice in this one is that when you add these down, the x's cancel out this time instead of the y's. Notice the x's cancel instead of the y's. That doesn't change how you do the problem, just make sure you're plugging things into the right spaces. So the sub is going to pause the video. You're going to go ahead and solve this one. Okay, this is what your work should look like. It should come out to be 1, 4. If you had 4, 1, you put these in the wrong spots. 4 is your y, 1 is your x. Okay, so 458 says, Annie needs your help. Annie was going to use the elimination method. Notice the setup of the problem makes sense for elimination. It doesn't say y equals or x equals. She was ready to add the same value to both sides of the equation to eliminate the x terms when she noticed a problem. They are both positive. Okay? 2 positive numbers do not eliminate each other. In order for you to eliminate, okay, you need 1 positive and 1 negative. Okay, so what we can do here is we can multiply. Multiplication will keep the equation the same value, but we have to multiply all numbers. And the number that we can multiply by is -1. So we can multiply this whole bottom equation. Don't multiply both the top and the bottom, otherwise you're going to get 2 negatives. So I'm going to keep the top of the way it is. 2x plus 7y equals 13. Okay. The bottom, I'm going to multiply everything by -1. So the positive 2x will become a negative 2x. The positive 3y will become a negative 3y. And the positive 5 will become a negative 5. And now, here's our elimination. The positive 2 and the negative 2. Okay, 7 and -3 make 4y. And then 13 minus 5. 13 minus 5 is 8. And then I can divide by 4. So I know my y is equal to 2. Okay, don't forget though, we're looking for a point. So the 2 is our y value. We're going to take that 2 and we're going to plug it in. Make sure you plug it in for the right variable, so it's got to go in for the y. So when I plug that in, it becomes 2x. 3 times 2 is 6 equals 5. Okay, I can subtract 6 from both sides. So I get 2x equals -1. And then I can divide by 2. And I get x equals -1/2. So -1/2 is my x value. And there is the point where the two lines intersect. Okay, last thing, we have a word problem that we have to work on. So, Pat was fishing in a competition at Lake Pisces. He caught some bass and some trout. Each bass weighed 3 pounds and each trout weighed 1 pound. Pat caught a total of 30 pounds of fish. He got 5 points for the competition for each bass, but since trout are endangered in Lake Pisces, he lost 1 point for each trout. Pat scored a total of 42 points. Okay, so let's highlight some important information here. We know that a bass is 3 pounds and a trout is 1 pound. And we know he has a total of 30 pounds. Okay, the other thing is he got 5 points for a bass. And trout, he lost 1 point for a total of 42 points. Okay, our question is, okay, write a system of equations to represent the information for this problem. So first we got to write our let statements. So we have 2 of them because we have 2 types of fish. Okay, I'm not going to use t because I don't like t's. It looks like a plus sign. So let's say x is equal to and y is equal to. Okay, so he has bass and he has trout. So let the x be the bass. Now, we know the weight of the bass and we know the point of the bass, but we don't know how many bass there were. So x is going to be the number of bass. Okay, y is going to be the number of trout. Okay, we don't need a unit of measure because we're actually counting the fish. So now we can come up with our 2 equations. So we know each bass weighed 3 pounds. So 3x, because x is the number of bass he caught, plus each trout weighed 1 pound, so 1y, gives us a total of 30 pounds. Okay, we know for points, he got 5 points for a bass, so 5x, but he lost 1 point. So he lost 1 point per trout, and he got a total of 42 points. Okay, so it says, is this system a good candidate for elimination? And you should say yes, because a positive 1 and a negative 1 cancel each other out. So when you can easily cancel stuff out, that's going to be a good elimination problem. So I'm going to add down. The positive 1 and the negative 1 cancel. So 5 and 3 make 8x. 30 and 42 make 72. I divide each side by 8. So I get x equals 9. So he has 9 bass. Okay, I also need to find out the number of trout. So I have to take that 9 and plug it back in. And I'm going to plug it into this top equation where x is. So 3 times 9, remember, don't write it out as 3 times 9. If you need to take out a calculator, take out a calculator. 3 times 9 is 27, plus 1y equals 30. Remember, 1y is just the same as y, so I'm going to subtract 27 from both sides. I get y equals 3. And now we can write out our sentence. So Pat caught 9 bass and 3 trout. Okay, once you're done with writing down that problem, you are going to go and complete the math notes on page 162. The title of that is the substitution method. Once you finish the math notes, then the rest of your time is to work on your homework worksheet. I will see you on Friday morning. Have a great day.